Hello and welcome to Unit 4, Lecture D. We're going to wrap up stoichiometry by adding in everything we've learned to chemical equations. Okay, so the first thing that we need to learn to do the stoichiometry with equations is about the mole ratio from the coefficients. So we've been saying it over and over again. The coefficients are a mole ratio. The coefficients in front tell us how many moles of each type of compound we have. And now we're going to use that ratio to switch from one type of compound to the other. So we can use our mole ratio just like any other factor label conversion. So when I look at this equation here, I'm just going to find my cursor. It says that there are 2 moles of sodium plus 1 mole of chlorine gas to produce 2 moles of sodium chloride. And the question wants to know what the ratio is between moles of sodium, so I find that in my equations right here, to moles of sodium chloride produced, and I find sodium chloride right here. And the coefficients are the mole ratio, so I just look those up. So my ratio is 2 to 2, or we reduce that down and it's 1 to 1. In the factor label method of writing this, I would say that for every 2 moles of sodium, I produce 2 moles of sodium chloride. Or I could say to produce 2 moles of sodium chloride, I need to use 2 moles of sodium. Equations are kind of like recipes for making things. If you were making cookies and you needed to use 2 cups of sugar and 2 eggs, you would have the same kind of ratio. And then if you needed to double that and you wanted to make 4 double batch, so you need 4 cups of sugar, you would need 4 eggs. It's going to be the same thing with equations. The coefficients are our mole ratio. Okay, so this question says for the same equation, what is the ratio between sodium and chlorine? So I'm going to change colors here, and they want sodium and chlorine. So here's the sodium again, and here's the chlorine. In this case, for every 2 moles of sodium, I need to use 1 mole of chlorine. So writing that factor label style, I would have for every 2 moles of sodium, I need to use 1 mole of chlorine. Or I could say for every 1 mole of chlorine that I use, I also need to use 2 moles of sodium. So nice and straightforward. So we're going to take this part, which is nice and easy. We just made new conversion factors. We just pulled things directly out of the equation. And we're going to put that together with our mole conversions. So moles to moles, grams to moles to grams, liters to moles to liters. We're just going to string them all together. All right, here's the basic steps for every problem that has an equation. When you have to do a stoichiometry problem and they give you an equation, I want you to follow these steps. Read the question. This is really important. Identify which compounds they're talking about. There's always going to be 2 of them. They're going to ask you about 2 things. We're going to start with an amount of one thing, switch to something else. Okay? So what you have data for and what you're trying to find data for. Circle those 2 things in the equation, and then use factor label, and that's it. So nice and straightforward. The rest of this lecture is practicing these steps. Read the question, identify what we're working with, find them in the equation for our mole ratio, convert. So we're going to convert from whatever units they gave us to moles. We're going to use the mole ratio from the equation to switch from one compound to the other. And then we're going to use that number of moles to switch back to whatever units they want for our question. The first type of problem we're going to start with are switching just from moles to moles. So let's follow the steps of my procedure up there and read the first question. So it says, how many moles of oxygen will react with 3 moles of CH4? So I find oxygen in my equation. I find CH4 in my equation. And then I start by writing down the one that gave us a number. So they're starting with 3 moles of CH4. Now it is the factor label method, so notice that I left all the labels. I left 3 moles of CH4. Next step says convert. Use factor label to convert. So I ask myself, am I in moles? Yes. The units that I have in my equation are moles, so I can use the equation to switch. My equation says 1 mole of CH4, so I'm going to put 1 mole of CH4 on the bottom because I want the CH4 to cancel. My equation says 2 moles of oxygen, so I put 2 moles of oxygen on the top because that's the compound I'm trying to switch to. Moles of CH4 will cancel. I do the math. 3 times 2 is 6. The units I have left are moles of oxygen. I ask myself what units do they want for my final answer. They want moles. I'm done. 6 moles of oxygen are my final answer. Simple as that. Straightforward. We're going to use the same procedure every single time. Next question's using the same equation. It says how many moles of water, so this is what they're looking for, can be produced from 6 moles of CH4. So CH4 is what we're starting with. I find water. I find CH4. I write down the one they gave me a number for. They gave me 6 moles of CH4. I ask myself, is this in moles? Yes, it's in moles. I can move on to the equation. I take the 2 things I circled in the equation. The part that I want to cancel goes on the bottom, so 1 mole of CH4 on the bottom. The component I'm trying to switch to goes on the top, so 2 moles of water on the top. Remember that even though the word mole is not written in here, the coefficient is a mole ratio, and when we read this equation, we read this as 2 moles of water. So that's why I keep writing mole in here. We cancel moles of CH4. I do the math. 6 times 2 is 12. 12 moles of water. This is just a ratio. There are other ways of doing this, but because later on we're going to add in conversions from grams to moles and moles to grams, I'm using the factor label method. If you want to just look at the equation and see that it's a 1 to 2 ratio and figure it out in your head, that's completely fine. I'm showing you the math and why this works and why the units cancel, so when we get to the larger questions later, it makes sense. Okay, next question. This one is going to use this equation right here. Given 2 moles of aluminum plus 3 moles of hydrogen sulfate, producing 3 moles of hydrogen gas plus 1 mole of aluminum sulfate, they want to know how many moles of H2SO4 will react with 5 moles of aluminum. So they want to know H2SO4. I circle H2SO4 in my equation. They have 5 moles of aluminum, so I circle aluminum in my equation, and I write down 5 moles of aluminum. This part of this procedure, I expect all of you to be able to do right up to this point. You should be able to read the question, identify what we're looking for and what number we're starting with, find those 2 species in the equation and circle them, and write down what we're starting with. If you come up to me to ask me a question and you haven't done at least this portion, I'm going to send you back because this is just straight reading. There's no chemistry or math knowledge needed to do this. You're reading, you're circling, you're writing down what we're starting with. Okay, next step is to check, are we starting with moles? Yes, we have moles. Having moles means we can use the equation. Then we use the equation to switch from aluminum to H2SO4. So 2 moles of aluminum. I want to cancel aluminum, so I put 2 moles of aluminum on the bottom. 3 moles of H2SO4. I want to keep H2SO4, so I put 3 moles of H2SO4 on the top. And now I do my canceling. So I have moles of aluminum that are going to cancel. Moles of H2SO4 are left. If I simplify this, I have 5 times 3 moles of H2SO4 over 2. And so I have 15 divided by 2, or 7.5. And the units I have left are moles of H2SO4. All right, simple as that. Now we're going to move on and add in the mole conversions that we learned back in Lecture B. So Lecture B, we learned to switch from moles to grams, grams to moles, liters to moles, moles to liters. We're just going to put all of the pieces from the unit together and do more involved problems. When we have problems that don't start with moles, they're not really any harder than the other problems. We're going to follow the same steps. It's just that you're going to have more than one conversion step. So I'm going to grab a calculator because we're probably going to need that for some of these problems. And we're going to follow through with the exact same steps. So we're going to start the same way we did before, which was by reading the question. So we're going to use this equation right here. And I know this is straightforward because all the coefficients are 1, but we're going to start easy. 1 mole of sodium hydroxide plus 1 mole of HCl produces 1 mole of sodium chloride plus 1 mole of water. The question says, how many grams of water are produced when 116 grams of NaCl is formed? So we find those two things in my equation. Here's the water, here's the NaCl, and I start by writing down, I have 116 grams of NaCl. My dogs are watching out the window and barking at who knows what. All right, next step. You ask yourself, am I in moles? Because the unit here is moles. And I'm obviously not in moles, I'm in grams. So then you say to yourself, well, how do I go from grams to moles? And of course, to go from grams to moles, we use the gram formula mass. So off to the side, I'm going to find the gram formula mass for sodium chloride. There's 1 piece of sodium. There's 1 piece of chlorine. Each sodium has a mass of 23. Each chlorine has a mass of 35. So 23 and 35 gives us a total formula mass of 58 grams per mole. The units are grams per mole. Gram formula mass is a conversion factor. So for every 1 mole, I have 58 grams. 116 divided by 58 should be 2. And so then I say, okay, I have 2 moles because grams are going to cancel. I have 2 moles of NaCl. Great, now that I have moles, I can use my equation and say, well, for every 1 mole of NaCl, I have 1 mole of water. And of course, for this equation, because the ratio is 1 to 1, this step is kind of a non-step, but what it really lets us do is cancel the units. So moles of NaCl cancel, and that means for every 2 moles of NaCl that I make 2 moles of water. So now I ask myself, do they want moles of water? They don't want moles of water, they want grams. So I'm almost done, but how do I go from moles to grams? Oh, that's right. To go from moles to grams, I use the gram formula mass, so I find the gram formula mass of water off to the side. 2 hydrogens at 1 each, 1 oxygen at 16. 2 and 16 give me a total formula mass of 18 grams per mole. So for every 1 mole, and this time I'm going to put the mole on the bottom, I have 18 grams of water. That's Trip. Moles are going to cancel, and 2 times 18 is 36 grams of water, and that's my final answer. So really, it's not any harder. It's just that instead of 1 step, I have 3. All right, I know that probably looks really difficult. The more of these we do, the easier it's going to get. So let's take a look at the next question. The next question wants to know how many grams of NaCl, so we're using the same equation, can be produced from 18 grams of HCl. So here's NaCl, and here's HCl, and I start by writing down what they gave me to start with, 18 grams of HCl. I ask myself, is this in moles? No, it's not in moles. So to convert from grams to moles, I need the gram formula mass. There's 1 hydrogen and 1 chlorine. Each hydrogen has a mass of 1. Each chlorine has a mass of 35. which gives me a total formula mass of 36 grams per mole. So I'm going to multiply this by every 1 mole having a mass of 36 grams. The grams cancel. 18 divided by 36 is 0.5 moles of HCl. Now that I have moles, I can use my equation. The ratio from the equation is that for every 1 mole of HCl, I have 1 mole of NaCl. And so then I look and the moles of HCl cancel, and I have 0.5 moles of NaCl. And I ask myself, do they want moles of NaCl? No, they want grams of NaCl. I already have the formula mass of sodium chloride over here. It's 58. So I'm going to multiply that by 58 grams per every 1 mole. The moles are going to cancel. And 0.5 times 58 is going to give me 29 grams of sodium chloride. And that's my final answer. One more question that goes just from grams to grams. So we start by reading the question. We have a new equation here. It says if I have 800 grams of calcium, how many grams of calcium oxide could be made? So I find calcium and I find calcium oxide, and I write down what I'm starting with, which is 800 grams of calcium. Next step, I ask myself, am I in moles? No, I'm not in moles, I'm in grams. So I need to switch 2 moles by finding the formula mass of calcium. When I look at my periodic table, calcium is an element, it's right here. It has a formula mass of 40. So we don't have to add up pieces because it's just an element. Why can't I find my cursor? There it is. So 40 grams go on the bottom and the 1 mole on the top, and grams cancel. And 800 divided by 40 gives me 20 moles of calcium. Now I'm going to use the factor from the equation. There are 2 moles of calcium for every 2 moles of calcium oxide. And again, I realize this is a 1-to-1 ratio, and if you see this, you can see it's a 1-to-1 ratio. Do I really have to do this step? Not really. I just show it anyways so that students see where this is coming from and how the units cancel. The 2 to 2 is going to cancel down to 1 to 1. The moles of calcium are going to cancel. And what I'm left with is 20 moles of calcium oxide. The question doesn't ask for moles of calcium oxide, though they want grams. So we need the formula mass for calcium oxide. 1 calcium at 40. 1 oxygen at 16 gives us 56. So I'm going to multiply this by 56 grams per mole, and the moles will cancel. And 20 times 56, we drop to 0, and that's 12. We carry the 1, 1,120 grams of calcium oxide. Okay, and you just keep doing that. That's all it is conversion, one conversion after the other, step by step by step. Just take your time and you'll be fine. All right, we're going to add in some of our other mole conversions now. And the one that will show up occasionally in the stoichiometry problems is volume of gases, because gases are much easier to find the volume of in lab than they are the mass because they're so tiny. So what you need to remember is that 1 mole of a gas has a volume of 22.4 liters. That's our conversion factor, and the rest of it just following through the exact same thing we've been doing. So let's take a look at this one. When 72 grams of water reacts completely with calcium. What is the total volume of hydrogen gas? Now notice they put in the word calcium, but they gave us a number for water, and they want us to find volume of hydrogen. So we really don't care about the calcium. We only need the thing they gave us a number for and the thing they want us to find. Why do they bother to write in the word calcium? Probably to confuse you, to see what you're going to do with it. We're not going to fall for that trick. I'm going to start by writing down the number they gave us, which was 72 grams of water. And we ask ourselves, are we in moles? No, we're not in moles, so we can't use the equation yet. So we're going to switch from grams to moles with the gram formula mass. The gram formula mass of water was, and I'll do it again, even though we've done it a bunch of times and it's right up there. Oops. 2 particles of hydrogen at 1 each is 2. 1 particle of oxygen at 16 is 16 for a total formula mass of 18 grams per mole. So I'm going to multiply this by every 1 mole has a mass of 18 grams, and 72 divided by 18 gives us 4. So I have 4 moles of water. Now that I have moles, I can use my equation. It says for every 2 moles of water, and I'm going to put the 2 moles of water at the bottom because I want water to cancel, we make 1 mole of hydrogen. So I put the 1 mole of hydrogen on the top because hydrogen is what they want us to find. Moles of water are going to cancel. 4 times 1 is 4 divided by 2 says that I will make 2 moles of hydrogen. Alright, so I have hydrogen, but do they want moles? Nope, they want volume. So to find the volume, we use our conversion factor over here of there are 22.4 liters of a gas in every 1 mole of gas. The moles cancel. 2 times 22.4 is 44.8 liters of hydrogen. Okay, 3 steps. So we went from grams to moles, step 1. From moles of one compound to moles of the other using the equation, step 2. From moles to liters using 22.4 liters per mole, step 3. 1 step at a time, you can do each of these steps. We did a bunch of conversions together in class. They're in lecture B if you need to go back and review it. You can do every single step. Just take your time and string them all together. Alright, next question uses the exact same equation. What is the total amount of calcium consumed? Generally, when they say amount, they want grams. This was probably a multiple choice question where all of the answers were in grams. Obviously, if they give you the answers in moles, then you just stop at moles. So amount of calcium consumed when 5.6 liters of hydrogen gas are produced. So hydrogen and calcium are the 2 parts that we're looking at, and we're starting with 5.6 liters of hydrogen. Okay, that's the easy part. Next part, we just take step by step. Are we in moles? No, we're in liters. So how do we get from liters to moles? 22.4 liters per mole. Where do I want to put the 22.4 liters? On the bottom. Why do I want to put the 22.4 liters on the bottom? So that liters cancel. And now that's definitely going to be a small number, so I want my calculator. 5.6 divided by 22.4 gives me 0.25. The units I have left are moles of hydrogen. Now that I have hydrogen in moles, I can switch from hydrogen to calcium using my equation. My ratio is a 1-to-1 ratio. For every 1 mole of hydrogen on the bottom, so moles of hydrogen cancel, I make 1 mole of calcium on the top because calciums are what they want me to find in my question. Moles of hydrogen cancel, and I'm going to have 0.25 moles of calcium. If it's a multiple choice question and moles are your choices, then you can stop here. If this is a multiple choice question and grams are your choices, you're going to have to convert from moles to grams using the gram formula mass of calcium, which just above we said was 40 grams per mole. So 40 times 0.25 is 10 grams of calcium. And that would be my final answer. Again, 3 steps. What you're starting with, convert it to moles. There's step 1. From moles of one compound to moles of the other. Step 2. From moles into grams. Step 3. Okay, another question. We're going to put all of the pieces together. What volume of oxygen, here's oxygen, is produced when 1 mole of PbO decomposes at STP? Here's PbO, lead oxide, lead 2 oxide. And I write down when I'm starting with 1 mole of lead 2 oxide. And I ask myself, am I in moles? And yay, this time we actually are in moles, so we can go directly to the equation. My equation says for every 2 moles of lead oxide, I create 1 mole of oxygen. The moles of lead oxide cancel, and 1 divided by 2 means I will make 0.5 moles of oxygen. I ask myself, do they want moles of oxygen? Nope, they want volume of oxygen. So to go from moles to liters, there are 22.4 liters per every 1 mole. The moles will cancel, and half of 22.4 is 11.2 liters of oxygen. This question only has 2 steps because we started with moles, so we used our equation to switch from moles to moles of one compound to the other, and then we used 22.4 liters to go from moles to volume, and there's my answer. Mass to moles just means we're going to stop when we have moles. So we're just going to read the question and do this exactly like we did every other problem. You notice the procedure's the same. The only thing that's different is what they're starting with and what they want you to find at the end. But the rest of the conversions are the same mole conversions we've been doing. So it says how many moles of oxygen are needed to react with 54 grams of aluminum. And I'm starting with 54 grams of aluminum. I ask myself, am I in moles? Nope. So I need to switch this to moles using the gram formula mass. The gram formula mass of aluminum is 27, so my grams are going to cancel, and 54 divided by 27 is 2 moles. I have 2 moles of aluminum. Now I can use my equation. My equation says for every 4 moles of aluminum, there are 3 moles of oxygen. Moles of aluminum are going to cancel, and I have 2 times 3 over 4 moles of oxygen, or 6 divided by 4, 1.5 moles of oxygen. And moles are what they want, so we stop and we're done. Alright, that's it. Sometimes you're going to stop right there at moles. Okay, there's one last shortcut. Now I'm going to show you full steps just like we've been doing, and I'm going to show them to you in a longer form. I'm going to do complete factor label where I do this as one big question. I know most of you are not going to want to do your work this way. And then I'm going to show you a shortcut, and this only works for volume to volume problems. If you think this is going to confuse you or you're going to forget, this is only when they give you liters and they want you to find liters, then just skip this last part, don't even watch it. This only works if they give you liters and they want liters. It only works when the 2 things you're looking at are both gases. Only works for gases and for volume to volume. If this will confuse you, ignore it and just do the problems the way we have at the beginning. Alright, that being said, here's how the shortcut works. This question wants to know what is the volume of the hydrogen gas when we use 40 liters of chlorine. So here's hydrogen, here's chlorine. I start with 40 liters of chlorine. Now when I do the factor label problems, I do this in one big long problem. So the first thing that I would do is say, well, that's not in moles. So for every 1 mole of chlorine, I need 22.4 liters. That is going to cancel liters, and I'm not going to do the math yet. I'm going to use the equation and then say for every 1 mole of chlorine, I make 1 mole of hydrogen. Now I say that's going to cancel moles of chlorine and give me hydrogen. Do they want moles of hydrogen? Nope, they want liters of hydrogen. So to find liters of hydrogen, I use 22.4 liters per every 1 mole, which is going to cancel the moles, and then I do the math all the way across. Now watch what happens when I condense this. I have 40 times 1 times 1 times 22.4 over 22.4 times 1 times 1. The 22.4s cancel, and I just have 40 liters of hydrogen. So the shortcut is when we are going from liters to liters, because we're not using formula mass where this number is different. It is always 22.4 liters for every gas. This conversion to liter or from liters and 2 liters will always cancel itself out. Always going to cancel. We can just, if we have liters and we know we want liters, we can just use the ratio from the equation and say for every 40 liters of chlorine, we're going to make 40 liters of hydrogen. Just a quick shortcut, only because that conversion factor is always the same. What volume of hydrochloric acid gas, so what volume of HCl gas is produced from 44.8 liters of hydrogen, and I'm starting with 44.8 liters of hydrogen. I can skip converting it to moles and just use the ratio from my equation. For every 1 mole of hydrogen, I produce 2 moles of HCl. 2 times 44.8 is going to give me 89.6 liters of HCl. That's the shortcut. One last problem using the shortcut, and then we're done for lecture D. Yay! How many liters of oxygen gas, and there's oxygen, would be required to produce 10 liters of NO, and there's the NO. So we're starting with 10 liters of NO gas. Since we have a gas and we're looking for a gas, we have liters, we want liters, we can use the shortcut and just say there are 4 moles of NO for every 5 moles of oxygen, and I took that from the equation. The NO cancels. I have 10 times 5 over 4 moles of oxygen. So 50 divided by 4, 12.5. 12.5 liters of oxygen. All right, I hope that last part didn't confuse you. I hope putting all of the little steps together to do the equation problems didn't confuse you. We'll practice lots of these together, and stoichiometry hopefully didn't scare you. It really is just algebra, and we've attached a bunch of chemistry words to it. You can do this math. It's not scary, and we'll be using it for the rest of the year.